Hello, this is Martha from the Academic Support Center once again. We're chugging along with our Pre-Calculus 1 final review. We're hopefully going to get through 17 and 18 within our given time slot. So let's get cracking. So for 17, we're given an equation, g of x equals 2 minus the square root of x plus 1. And the first thing that we're supposed to do is find the domain. And our domain are our x values. When we look at our domain, we want to see where there are going to be problems. If we're going to have 0 in the denominator, that's going to be a problem. If we're going to have a negative under an even radical, like negative under a square root, that's going to be a big problem. So we find and address that. So we set this, the square root of x plus 1. The lowest that can be is 0. So we want to set what's inside equal to 0. And we know that everything above that works. So we've got x plus 1 equals 0. We subtract 1 from each side. We get that x equals negative 1. And if we put negative 1 in there, we get 0. And you can take the square root of 0. But anything smaller than that, even negative 1.001, that's going to result in a negative under the radical. So if we look at our number line, we know that negative 1 is included. So all of this over here works up to positive infinity, but anything below that doesn't. So in interval notation, we've got the hard bracket, negative 1, comma, infinity. And infinity gets the soft bracket or the parentheses. And that's the domain. Now we're going to look at the range. The range on this one can be a little tricky because we've got this 2, and then we want to take our lowest possible x, and that's our lowest possible there. So we've got 2 minus 0. And how does that help us? We know that our domain or our y values are 2 and anything below 2. Now let's look at y. If let's just pick a random number and we'll go from there. So if we say, let's let x equal 8, we've got 2 minus the square root of 8 plus 1. Well, that is 9. So when we take the square root of that, we get 2 minus 3, and that gives us a negative number. Any number that we put in is going to result in 2 or below. And that's how we find our range. Now we're going to find our x and our y-intercepts. So we'll do x, where we set the y equal to 0, or the equation equal to 0. 0 equals 2 minus square root x plus 1. Now we're going to add this square root of x plus 1 to each side. And that gives us the square root of x plus 1 equals 2. Now, in order to keep our equation balanced, if we do the same thing to each side, we're still within the rules. So if we square each side, that gets rid of the square root. And we get x plus 1 equals 2 squared, or 4. And we solve for x, where x, we subtract 1 from each side. And that gives us x equals 3. So we know that our x-intercept is 3, 0. Now we're going to do our y-intercept. And for that, we just put 0 in for x. So we've got y equals, 2 minus 0 plus 1. Now, 0 plus 1 is 1, so we've got, moving along, 2 minus the square root of 1, or 2 minus 1, meaning 1. So we know that it's going to hit the y-axis at 0, 1. Now we have to graph this. How do we do that? So let's put our nifty x and y axis up here, and let's plot what we know. We know that it hits at the y-axis at 1, 0. It hits the x-axis at 3, 0. The highest that it can go is -1 for our domain and +2. So we know it's going to start here, and then it goes down. Let's draw that a little bit better. Down to -infinity. And that's how we graph that. So those are the steps for finding the domain, range, the x and y intercepts, and then using that to graph it. Now we're going to need a little space for this next problem, so let's clear it up a bit. This one has a lot of steps. So 18, we're given two equations, f of x and g of x. And we're going to make composite functions. The first, a, we're going to take f of x plus g of x. So we just add them together. So that gives us 2x minus 4 is our f of x. And we add 1 plus 3x. For this, it's a simple process of combining like terms. We have 5x plus 2x plus 3x, which gives us 5x. And -4 plus 1, which gives us -3. So that's A. Now let's look at B. We're going to have f of x minus g. And it's important how we set this up. So let's set it up. We're going to want to use parentheses on this. So we get f of x comes first. So that's 2x minus 4. And then we have to remember to subtract the whole of g of x. So -1 plus 3x. We distribute this negative through. And rewriting it, we get 2x minus 4 minus 1 minus 3x. Combining like terms, we've got a 2x and a 3x. That gives us -x. And then we've got a -4 and a -1, or -4 minus 1, giving us x minus 5. Now, C is we're just multiplying those functions together. So let's do 2x minus 4 times 1 plus 3x. And this is just simple foiling that you've been doing for a while. So we take 2x times 1, which gives us 2x. 2x times 3x, which gives us positive 6x squared. And now we're going to do this -4. -4 times 1 is -4. -4 times 3x is -12x. And we're just going to go combine like terms. We've got 6x squared. We've got two x's. We've got a positive 2x and a -12x. When we combine those, that ends up giving us a -10x. And then -4. And that's our answer for C. Now D is division. Kind of like how they put that there. And it's f of x over g of x. We need to just remember which one goes in the numerator and which one goes in the denominator. And in this, we get 2x minus 4 over 1 plus 3x. There's not any simplification we can do really besides pulling a 2 out of the top. And so that's our division. Now E can get a little tricky. This f of g of x. Sometimes it's hard to know which one to put in. And for this, the g goes in wherever there's an x for f. So we're going to write out f of x and leave space for that g. So we've got 2. And what are we going to put in our x? And then -4. And our g of x goes in for x. So 1 plus 3x. And then it's just a process of simplifying. Foiling and simplifying. 2 times 1 is 2. 2 times 3x is plus 6x. And then -4. Combining like terms gives us 6x. And positive 2 minus 4 is -2. And that gives us, there we go. So f of g of x is 6x minus 2. And to give a little bit more space, we're going to move this over here. we need to find the inverse function. That's that little f to the -1, the inverse function of f. So f is 2x minus 4 equals y. To find the inverse, we swap the x and the y and solve for y. So we've got 2x minus 4 equals y, so we're going to say 2y minus 4 equals x. We solve for y, so we're going to add 4 to each side. We get 2y equals x plus 4, and then we divide everything by 2, and we get that y, or our f inverse up here, is equal to x plus 4 over 2. Now you can simplify this to 1/2 x plus 2 if you'd like. That's okay. For our purposes, we're going to leave it the same because in our next part, G, we need to verify that f of x and f of the inverse of x are functions. So this is what we do. We put our inverse in for our x. And if we get just x back, then we know that it's the inverse. So we get 2, and then we're going to put our inverse in, x plus 4 divided by 2, minus 4, and we solve. The 2's here will cancel out. That leaves us with x plus 4 minus 4. Plus 4 minus 4 cancel each other out, so that's how we get x. And that is how we verify that the functions are inverses of each other. Now the last part, we're going to graph. It says graph f and the f inverse of x on the same coordinate system. What is the relationship between their graphs? We're going to try and move a little quickly because of time's sake. Let's look at 2x minus 4. We know that the that the y inverse is at -4, or the y-intercept, hello. And we know that we go up 2 over 1, up 2 over 1. And that's going to hit, okay, there. That's going to hit at 2, 0. And now we've got 2 points. That's all we need for this line. We're going to go, there it is. Now let's graph the inverse. And we're going to write this as 1/2 x . 1/2 x plus 2. And we do this because it's easier to graph that way. We know that it's going to hit the y-axis at 2 because that's our b. And we know that it's going to go up 1 over 2. Up 1 over 2, that gives us 2 points. And then we have graphed our f and our f inverse. Something important to note is that these are symmetric about the line y equals x. And that's true for the inverses. So they're reflections of each other about the line y equals x. Or the domain and range of the function, so the domain and range of the green line, become the range and domain of the inverse function. I hope this is helpful, and we'll have fun. We'll talk again soon.